I don't think you've ever seen, oh, maybe you have in Algebra 1 a little bit, but I'm going to assume you've never seen it before in your life. Yes. Piecewise functions are functions that come in pieces, okay? There's different pieces. So here we have our first function, a piecewise function. It'll always say whatever equals, and it'll be bracketed with different kind of equations depending on where we are on the graph. So if your x's are between -3 and 0, we use this equation. If the x's are between 0 and 4, we use the second equation. So we're going to complete this table of values. X equals -3. Now look at your intervals. Does -3 fall in the first one or the second? First one. So when we are trying to fill in our table of values, we plug -3 into here. So -3 minus 3 is -6. -2 falls in which interval? First. -2 minus 3, -5. -1 also falls in that interval. -1 minus 3 is -4. Now 0 is a question mark. I'm going to let you tell me, because it's kind of written in both of them. Which equation do we use for 0, Isaiah? And why? What's your logic? Perfect. So this one includes anything that's less than 0, but not 0 itself because it lacks the or equal to. So we're going to plug 0 into here. We get 4. 1 falls in this interval, so we plug 1 into there. A half times 1 is a half, plus 4 is 4.5. I'll write 4.5. When I plug in 2, I get 1 plus 4, which is 5. Plug in 3, I'm going to get 5.5, and 4, I'm going to get 6. Okay? Now it comes time to graph this. Now, our two pieces kind of split here, yes? And I'm going to circle that 0, 4 for both pieces, because 0, 4 is the border for both of them. And the difference in how we show this on the graph is critical. So plot -3, -6. Does our domain include -3 or not? Because this is important on our plotting of the point. -3 is included. So solid circle or open circle? Solid. And then -2, -5. -1, -4. Now 0, 4 on our first piece. Is that included or not? Not included, right? Because it's that less than. We don't have the or equal to. So I'm still going to plot 0. Should it have been -4? Oh, no. Backing up, sorry. I used the second equation to come up with that number. If I were to have used the first equation and plugged in 0, what would I have gotten? 0 comma what? -3. So I'm not going to plot the point as a I'm still going to plot 0, -3 because this graph goes up until 0, but I'm not going to do it as a solid circle. I'm going to do it as an open circle because this graph ends at 0. It's everything up until 0. So I want to plot like -1/2, but I want it to stay an open circle. And then I'm really going to do it as a solid circle, 0, 4. And 1, 4.5, and 2, 5, 3, 5.5, and 4, 6. That's another endpoint. Is it open or closed? Michael, what'd you say? Closed, good. And then I'm going to connect those. The open or closed is critical. Now, this is still a function because it passes the vertical line test. The only place where it's questionable is right on the y-axis, but because this one is open, and this one is closed, it's still technically only hitting the graph one time. Yes? Okay. Why am I not putting arrows at the end? Lydia? Right. Perfect. It's got a starting point, solid point, ending point, open. And then this one's got a starting point, closed circle, ending point, closed circle. So we have no arrows on the end. Now, the domain here, I know this says range, but the domain is from, what's the lowest point to the left? -3. Is that included? Yes, we use brackets. Up until 4, and that's included. Our range is going to be a little bit different. And here's why. Because if I just go lowest to highest point, I'm including a bunch of y values that were actually never touched. Do you see that gap there? Yes? So my domain needs to be split up into two parts. There's this lowest level of -6. Is that included? Yes. Up until -3. Is that included? No. Good, Mason, because that's an open circle. And then we have to union that with our range up here, which is from 4, that is included, to 6, that is included. Does this make sense? Okay? So piecewise functions come in pieces. You determine what piece to use based on the intervals that they kind of tell you where your number falls. All right? Let's skip exercise 2 for now. We'll come back to it. There's a couple more critical things I want to get to, and by critical I mean I'm just guessing based on the regions what is critical. But exercise 4 here gives us another piecewise function and asks us to find all the solutions to when this function equals 1. So they're telling us the y-coordinate. That's the y-coordinate. When does this function equal 1? We're not plugging 1 into it. Do you see the difference? It's not asking us for f of 1. That would be plugging 1 into it. It's asking us, when does this function equal 1? So because we have two pieces, I'm going to kind of have to work on this twice. On the one hand, I'm looking for where -2x plus 10 equals 1. On the other hand, I'm looking for where 5x minus 1 might equal 1. So we're going to solve each of these, and then we're going to have something to think about and discuss. So subtracting my 10 from both sides and dividing by -2, that's happening at 5.5. And on this one, I'm adding 1 to both sides, dividing by 5, and I'm getting 2/5, which is 0.4. Nathan. Did I screw something up? Oh, I did. Thank you. Sorry. -9, 1 minus 10. 4.5. That's good. I need auditors. Hopefully I have 25 of them in here. Keep me on my toes. Now, one of these answers we have to throw away. One of them is not actually true. Anybody think they might know why? This might be a long shot, but maybe some of you can figure this out. One of these I have to throw away. Not always. Sometimes they'll both be good. Nathan, what do you think? This one. Why? doesn't have to be equal to, it just has to be greater than. The answer to this piece just has to be greater than, so it is greater than. But he's definitely on the right track, Isaiah. Correct. So in this equation, very good, this would equal 1, this line, if you kind of take a quick peek at the line negative 2x plus 10, has a y-intercept of 10 and a slope of negative 2, right? This one would equal 1 over here, and it would be at the point 4.5, but this piece, this line, is only good when you're less than or equal to 0. So this piece really wouldn't even exist. Yes? Since that answer of x equaling 4.5 isn't in the interval, we need to reject that. So Nathan, the reason you gave me is actually why we do keep this one, and you kind of caught yourself. You're like, oh wait, no, it is bigger than 0. Any x answer that we get for this one has to satisfy that. If it doesn't, we have to reject it. Okay? So in other words, kind of what I showed here, the line in isolation would equal 1 at 4.5. But given that we're only looking at this certain piece of it, and that point in that piece is not included, we have to reject it. Does that make sense? Sometimes you'll reject both of them. Sometimes you'll reject one, or sometimes you'll keep both of them. They'll both be good. But you have to go back and evaluate if that x value falls appropriately in the interval that you're keeping. Yes? Okay. Excellent. Exercise 3 here. Piecewise function given. Determine the y-intercept. Okay, this is on your flashcards. The front says y-intercept. What does the back say? X equals 0. So we need to set x equal to 0 to find the y-intercept. Now, because we know we're plugging in an x of 0, which interval does an x of 0 fall in? Is it less than 2 or is it greater than or equal to 2? Less than 2. So when we find the x-intercept, we're plugging into this one because 0 is less than 2. So we would do 5 minus 0, and we would get 5. So that's our answer, 5. The x-intercept is, or the y-intercept rather, is 5. Why can a function only have one y-intercept? I think we kind of talked about that the other day. What was the reason? Because if it had more than one, it would fail the vertical line test. If you had a point here and a point here, 2 different y-intercepts, you'd fail the vertical line test. Good. B says find the x-intercept. Another flashcard. If you're looking for the x-intercept, you set y equal to 0. Now here, it's kind of going to be like this problem. We have to wait and see. We're setting each individual equation equal to 0 because they're both y equals. And we're going to solve both. This one I'm just going to add x to both sides. I get 5 equal x. That was an easy one. And on the other one, subtract 2. How do I get rid of 1/2 again? I know we sometimes struggle with that. Multiply by the reciprocal, so 2 over 1, which is just 2. So negative 2 times 2 over 1 is negative 4. Now, are both of these okay? Are only one of them okay? Are neither of them okay? Take a minute. Process whether or not you think we need to reject either of these or both of these. Take a minute on your own, because it does take some thinking. We're going to have 4 options here. Either you think both of them are good, or you think neither of them are good, or you think just the 5 is good, or you think just the negative 4 is good. Okay? Raise your hand if you think they're both okay. Raise your hand if you think neither are okay. Excellent. Good. So it looks like for the majority of us, we've picked up on that. So 5 minus x, this comes with a restriction that x has to be less than 2. If we get x is 5, and that's not less than 2, which it's not, we have to reject it. On this one, x equals negative 4. That comes from an equation where x has to be greater than or equal to 2. Is this number greater than or equal to 2? No, we have to reject it. So there are no x-intercepts here. Okay? There are none. We're going to graph this and see why. Now, this kind of opens a little bit of a can of worms. I'm just going to pray and hope that you remember how to graph a line. That's possible that you don't. So if we're graphing 5 minus x, where do we start? The 5. Because this is mx plus b, right? This is the same thing as negative x plus 5. So we start with the y-intercept of 5. 1, 2, 3, 4, 5. Make sure you're not using pen. When you're graphing piecewise functions, please don't use pen, because I'm going to have to erase different pieces. And then where do I go from here? Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and so on. So again, pencil, 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 because I'm going to erase. This is the line in its entirety, right? But the restriction on this line says that we only want to see this line when x is less than 2. Okay? So x being 2 is right here, agreed? We only want to see this, and this only applies when we're less than 2. So we need to erase this part of the line. And we're going to have a point at 2, but is it going to be open or closed? Open. So make it a very obviously open line. And are we all understanding why we would use an arrow this time? Okay, it's not a start and an end interval. It's just anything less than 2 till eternity. So hence, we have an arrow. Now the second line has a y-intercept of what, Aiden? 2. So I'm going to go to 2 there. And a slope of what? Fred? What's the slope of this second line? Nope, that was the y-intercept. That was our b. A half. So that means from here, go up 1 over 2. Hey, look at that. What's going to happen right here? It actually is going to fill that circle, right? It's going to cross that same spot. We'll wait to do that, but up 1 over 2, up 1 over 2, up 1 over 2. So here again is that line in its entirety, but we only want to see that line where x is greater than or equal to 2. So anything that's less than 2, we need to get rid of. And my graph is still going to start at 2. Is this one going to be an open or a closed circle? Closed. So now it's hard to tell that the initial one was open, but this one is closed, because where one ends, the other's beginning, but that's okay. If it's open for one but closed for another, you got to close it, right? Now here, when you graph a piecewise function, when you're done, it better pass the vertical line test. And this does, okay? If it doesn't, you did something wrong. Because where one interval ends, the next one typically begins. Yes? Okay? Why does my graph contradict? Okay, so they're kind of pointing out. So we got that this line would have had an x-intercept of 5, and it would have. But do you see how it got cut off? Because of the interval. This line would have had an x-intercept of negative 4, but it got cut off because of the interval. So visually, I'm hoping you can see now why there is no x-intercept. Are we good? All right. So E is just kind of building us up to what I've already talked about. Any questions there? Okay? I want you to flip back now to exercise 2, where we are given the picture. And by the way, if you can't see it, there is a flat line right here. Okay? How many pieces are there in this graph? Cameron, what do you think? How many pieces? Where are they? From what to what? Give me intervals. Well, let's start this piece. So from an x of negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8 until negative 1, 2, 3, 4, 5. So just this piece here, that's your first piece? Okay, to here. All right, so there's your first piece. And where's your second piece? From what? Negative 2 to 3. 3 to 6. Okay. So you take back your original answer. There's 3 pieces, right? Okay. So what he just did is huge, actually. F of x equals. We have 3 pieces. My recommendation is to always start with your intervals. So just like Cameron just told us, this first piece is going from negative 8. Is it less than x or less than or equal to x? Is that a solid dot or an open dot? Solid, so less than or equal to x. Up until negative 2, he said. Is it less than negative 2 or less than or equal to? Okay, if we're going with less than or equal to, that's fine. But I'll talk in a minute about how that could vary from person to person, right? Because when I pick up this next line that starts at negative 2, I can't also use a less than or equal to on that. Because then it would be very confusing. If I did use a less than or equal to, and someone asked you to evaluate f of negative 2, it's like, well, geez, now I don't know. Do I plug it in for this one or do I plug it in for this one? You can't have it both ways. It's one or the other. So because it's kind of where one ends and the other begins, you can't tell, like the last one we just graphed, which one's open, which one's closed. You follow? And so it really doesn't matter. It's just one has to be open, one has to be closed. So since Bo said, did I just call you Connor a minute ago? Sorry, I just realized that. Since Bo decided for you all, because he's the closest one to me and I heard him, to use a less than or equal to right there, we have to use a strictly less than on this side of things. You can't have it both ways. And that piece goes up to 3, Cameron told us. And again, we have a choice. Do we want to keep it less than or equal to? Again, it doesn't matter at 3. I'll just keep it less than. So when my third piece picks up at 3, I am going to include that there, and it's less than or equal to 1, 2, 3, 4, 5, 6. Set your intervals first, okay? And then I'm opening a little bit of a can of worms, because do you remember how to write equations of lines? You do? Okay. What's the equation of this line, Mason? 3 over 2x plus 7. So he said his slope was 3 halves, which you can see quickly, 1, 2, 3 over 2. Very good. How did you get the 7? Okay, so even though it doesn't run into the y-axis, he kind of projected as if it was going to. So if he kept going up 3 over 2, it would have crossed there. And so he used 1, 2, 3, 4, 5, 6, 7 as his y-intercept. Awesome. Does that make sense? Okay. Here's another can of worms. How do you write the equation of a horizontal line? Just the number, perfect. And the number is that y-intercept, that horizontal level is 1, 2, 3, 4. So it's just f of x equals 4 there. That's like y equals 5 is a horizontal line at 5 and so on. And then I want everyone on their own to take a minute to try to write the equation of this third piece. Raise your hand if you got something. Raise your hand if you're stuck. All right, talk to me, John. Were you able to get the slope or the y-intercept, either one?
Yeah, I had the slope.
As what?
-2/1.
Perfect. So because this is going down 2 over 1, it does have a slope of -2. We don't really need the over 1. So the y-intercept was the tricky part, yes? Same for you, Zach? Okay. So if I were thinking about extending this and kind of continuing to go through this pattern, over 1, up 2, over 1, up 2, over 1, up 2, and I kept that going, over 1, up 2, over 1, up 2, over 1, up 2. And I do run off the graph a little bit, but can you count that now? Where is it crossing? 10. Does that make sense? Nice job. Let's just for a moment pretend like what if it was like way up and you didn't have counting to your benefit? Writing equations of lines. Write this formula down. Y minus y1 equals m times x minus x1. You ever seen that before? Yes, Mrs. Grisanti, who taught a lot of you geometry, says, yes, you have. Probably not the way you originally learned how to write equations of lines. You probably used y equals mx plus b. But this is the most efficient way to write an equation of a line because you need the slope and you need a point. Any point that's on the line. Doesn't have to be the y-intercept. That's the limitation of y equals mx plus b. B has to be the y-intercept. What if you don't know the y-intercept and you're trying to find it, right? So for something like this, when we just knew that the slope was -2, we need to pick any other point on the line. Now here's an easy one. 1, 2, 3, 4, 5, 0. That's your x1, y1. So x minus 5, y minus 0. And then we just solve for y. So I'm going to distribute the -2 and add the 0 over technically. And I know you guys could count this one, but you can't count all of them. But you see how that just morphed into the same equation we just had. Okay? This is going to be a flashcard. This is called point-slope format. And that's the way we use, that's the one we use to most efficiently write the equation of a line. Is that clear? So, it's not on the original flashcards that I put up there, so it won't be on next week's quiz, but it will be on quizzes moving forward. You have to memorize that format and then, of course, know how to use it. Now, I didn't spend a whole day on that because it should be review. But this is still always golden. Assuming you guys know nothing, to be safe. The vocab list is on my website and it that's where it is. shouldn't have said vocab quiz. I should have said flashcard quizzes.